All right, the very last one we're going to cover here is powers to powers, which is like the last part of properties of exponents. So if I take a power raised to another power, okay, what you're doing is you're just making a really big multiplication problem. And since we already know from the previous video how to multiply exponents, you're just kind of doing like a mega exponent multiplication. So what I'm talking about is if you ever see a problem that looks like this, for example, x to the third raised to the fourth power. So what that's saying is, remember, because an exponent says how many times to multiply something by itself, what this is saying is that I have x to the third times x to the third times x to the third times x to the third. Now, if you go back to our multiplication lesson, you'll realize that if I wanted to, I could expand this even more and put x, 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 x all the way across. But since we don't need to do that anymore, we know that if we have the same base and we're multiplying the exponents, so we add all these numbers together. So this is going to be 3 plus 3 plus 3 plus 3. Well, 3 plus 3 is 6, 6 plus 3 is 9, and 9 plus 3 is 12. So this is x to the 12th power. Hopefully, some of you realize, and you may not, and that's totally fine, some of you realize that 12 is the same as 3 times 4. So the shortcut to this way is, when taking a power to a power, you keep the base and you multiply the exponents. That's the shortcut version. Keep the base, multiply the exponents. Now, if you have two different variables raised to an exponent, you have to do the same thing to both of them. And I'm going to show you what I mean here with an example. So for example, let's say that I have, I'm going to do a really tough one. I have x to the third, y to the second raised to, and we'll put it over. Actually, no, we're not going to do that yet. We'll do it this way. X to the third, y to the second raised to the, let's do the fifth power. Okay. I don't want to write each of these out 5 separate times because that seems ridiculous. So what I'm going to do is I'm going to remember my shortcut, and my shortcut is to keep the base, multiply the exponents. So what I'm going to do is I'm going to keep my x, I'm going to keep my y. I'm going to take 3 times 5, and so that's actually 15 x's. And I'm going to take 2 times 5, and that's 10 y's. So my total answer here is x to the 15th and y to the 10th. Okay, so now I'm going to do a very, very tough example. It's going to incorporate a negative exponent, a division problem, and a power to a power. And I'm going to show you how to simplify, and that'll probably be one of the toughest kind that you see. So I'm going to show you how to simplify one that includes a negative exponent, division, and powers to powers. And hopefully it makes it a little less difficult for you guys. Okay. So if I have x to the fourth, y to the negative second, and z to the third, and I'm dividing that by x to the second, y to the third, and z to the negative fourth, and I'm raising all of those to the third power. That is a crazy looking problem. And I don't know about you, but if I didn't know what I was doing and I didn't know how to break this down, I would just skip this problem, or I would be like, I'm never going to be able to know how to do that. But hopefully the way I show it to you, it makes it a little easier, and so you won't give up when you see a problem like this. So the very first thing you're going to do is simplify any of the stuff that's in here in the fraction. Do not worry about the power outside yet. So what I see when I look at this, and let me get a different color marker so I can show you. What I see when I look at this is I see a negative here that needs to be moved. I see a negative here that needs to be moved. And then I see x's that need to be simplified. I see y's that need to be simplified. And I see z's that need to be simplified. That's a whole lot of stuff to do before you can even answer the problem. So let's start with those negatives. If I'm going to rewrite this, and I don't want any negatives back in my problem anymore, this x to the fourth and this x to the second, well, they're just going to stay the way they are for now. Okay. This y to the second, remember back on our negatives, if it has a negative exponent, it moves opposite and becomes positive. So I'm going to take this y to the second, and I'm going to move it down here with these three y's that are already here. So now I'm going to have 5, or y to the 5th power, down here. Now those y's are done. So I've taken care of the x's, I've taken care of the y's. These 4 z's that are down here, they have to move up because they need to move opposite. So I already had 3 of them here. I'm bringing 4 more up. So now I have 7 z's. Hopefully you're so far so good. And I'm still raising all of that to the 3rd power. Now, again, I look in here. Are there any simplifications that I can make? And there are. And hopefully you're answering me from home and you're saying, yes, yes, I have to simplify the x's. So if you notice, I still have x to the 4th here, and I still have x to the 2nd there. Okay, so x to the 4th and divided by x to the 2nd. Remember, when I'm dividing, I'm canceling them out. So I can cancel all 2 of these out, and then I need to take 2 out of here. So my fully simplified fraction, not even to the power yet, my fully simplified fraction is going to be, I'm going to move over here. It's going to be x to the 2nd, z to the 7th, over y to the 5th, and I'm going to raise all that to the 3rd power. Okay, so we just moved from step 1 here. This is step 1. This is step 2. This is going to be step 3. Okay, so if you're getting a little confused with my organization here, I'm going to break it up like that for you. Okay, so now we're over here. Our very last step is to get rid of that outside exponent. And remember, I just multiply these together. So I'm going to take 2 times 3, and I'm going to get x to the 6. I'm going to take 7 times 3, and I'm going to get z to the 21st. That's a terrible looking 21. Sorry about that. And then I'm going to draw my line because it's just the same as it is in the problem. And I'm going to take my y to the 5th and multiply that by 3, and that's going to be y to the 15th power. And then I have nothing else I can simplify. I have nothing that are same bases that I can combine together. I have no more negatives. I have no more powers that are outside of the parentheses. I'm good to go. This right here is my final answer. Hope you guys have a great day, and I will see you next time.